Hi guys, thank you again for behaving for the sub. So today you're going to be using the Phet Simulation Energy Skate Park. And so you are going to click this link, which is going to pull up the Energy Skate Park simulation over here. And you want to click the Intro tab. That's where we're going to start. So as you look through the document, you'll see questions that are highlighted in yellow. This is where I expect to see answers. So underneath everything that is highlighted in yellow is something that I want you to answer. If it's not highlighted in yellow, it's a guiding step. So steps that you have to follow. So you are going to make sure everything that is yellow has an answer underneath it, including your conclusion paragraph, which should be 4 to 5 sentences. Okay, so first thing you guys want to do, explore the simulation. Some things that you can do, you can of course change your little avatar person. I'm going to be the dog because that's super cool. And then some things that you always want to have checked during the simulation. You always want to click the plus for energy. You want to click the grid. And then you want to have your speed checked. Okay, so these are things that you should always have checked in the simulation. You also want this little pause symbol right here to be a plus, because when you place your object on the ramp, you don't want it to start off right away. So you always want to see the play symbol right here, so then when we're ready, we can start the simulation. So some questions that you're answering right off the bat. What happens to potential energy bar graph when you increase the skater's height on the ramp? So having the grid checked, this 2, 4, and 6 are different heights. So to answer that, you're looking at your graph as you move your object to those different heights and seeing what happens to the potential energy as you increase the skater's height on the ramp. So you would give me a full sentence answer. Okay, what types of energy are listed in the bar graph? Well, what types of energy do we have here? Which ones match your vocabulary words? Total isn't really a type of energy, okay? So total isn't a type of energy. Total would be the sum. And you'll notice that here I have my little dog at the 6 meter mark. My total energy, if I hit play and let my dog go down the ramp, nothing can ever exceed your starting total. Okay, so whatever your total was to start with, nothing will ever go above that total. So your potential energy, where you start your skater, sets that total energy. Now, you'll notice that thermal is not moving right here. Well, that's because thermal energy is friction, and I don't have any friction turned on. So if I turn on the friction, you'll notice that it slowly begins to increase. Well, on Earth, friction is the force that slows everything down. Friction always opposes movement. So friction is what causes everything to completely come to a stop at some point. Okay, we don't have friction in space. So if this dog skateboarded off a ramp in space, it would keep going until it slammed into a planet or a star. But on Earth, we have friction that's going to eventually slow everything down. And we can see that here because my thermal energy is now equal to my total. So you don't need any friction while we're doing this experiment. So you can leave that friction turned off for right now. So your third question asks you, how is the skater's motion different in the U-shape ramp versus this L one? Right here is our ability to change ramps. So we can change to the L-shape ramp, you can change to this ramp, and you can change to the little loop-de-loop. But really that's just asking you to compare these two ramps. So looking at your skater's motion in this ramp, versus your skater's motion in this ramp. What is the difference in their motion? So explain what you see. Okay, then it says reset all settings. So remember, whenever you reset all settings, that means you need to click the plus, you need to click the grid, and you need to click the speed. Okay, in this case, the next couple of questions are going to focus on this L, and we want to make sure our screen is paused. So it says, then place the skater at the 6-meter mark. Okay, notice it's a height reference, so it's the height of your ramp. So we're placing our skater at the 6-meter mark. Then it says, graph the energy the skater has. Insert a screenshot. So you are going to take a screenshot. You are going to hit Control, Shift, and the button above the number 6. It's a little box with 2 lines after it. That's your Change Screens button. That's going to allow you to take a screenshot. And when you take a screenshot, I want you to screenshot this section right here. So that's what I'm expecting to see in your screenshot. You would then capture that and place it into your document by pasting it in there. So, or you can go up to the insert right here. You can go up to insert, or you can click and insert that image. So you'd upload it from your drive, because it's of course going to save to you guys' drive directly. And then you would place that screenshot in the document. Now, once you have that screenshot in there, it asks you what's the relationship between height and energy on the graph. So what relationship do you see here going on? Then it says let your skater go down the ramp. So hit the play, let your skater go down, and then you are going to graph the energy the skater has when he finishes going down the ramp. So you take a screenshot of this graph, and then you would, of course, explain the relationship between height as the skater finished and the energy shown on the graph. So now what is that relationship as we went down between height and the energy that we're seeing here? Okay. It says, try dropping the skater from different heights on the ramp. So we don't have to take a screenshot of this now. It just wants us to try dropping the skater from different heights. So that would be the 4 and the 2. It says, what happens to the potential energy as you decrease the starting height of the skater? What happens to the kinetic energy as you decrease the starting height? So remember, to get the kinetic energy, we have to put our skater on the ramp, and then we have to hit play, and we're able to see that kinetic energy relationship between the starting energy. So you're going to explain that. Okay, now I'm going to reset my skater. Okay, I'm going to reset my skater. I'm going to put him at the top of the 6-meter mark. Now it says, try changing the mass of the skater as you have them skate down the ramp. So to change the mass, you can change this right here. I'm going to do the dog. Now, when you change the mass, it makes it bigger, makes it a little bit smaller. So you're going to change the mass. Okay, what do you notice about kinetic energy of the skater as you increase the mass? So remember, we can't determine the kinetic energy until we let them go down. So what happened to the kinetic energy as the mass increased? And then what do you notice about the potential energy as you increase the mass of the skater? So what happened to kinetic and potential energy as we increase the mass of our skater? You're going to have to use the simulation to figure out. Once you finish that, you're going to open the ramp again. So when we're going back to this U-shape ramp, it says drop the skater at the 6-meter mark. So I'm dropping them at the 6-meter mark. And then I'm going to, of course, hit play. What law can we apply to the skater as they move back and forth on the ramp? Explain why. So look at your vocabulary. What law relates to this and why? Look at your graph. What's going on in your graph here? Okay, so you're going to write at least a sentence there. Conclusion paragraph. You should write one paragraph explaining how the simulation allowed you to see the evidence that mass and height affect the amount of potential energy and mass and speed affect the amount of kinetic energy. Vocabulary to include potential energy, kinetic energy, mass and speed, and the law of conservation. So if you aren't sure of where to start, Okay, start at the beginning. So what did we use this simulation for? So explain why we're doing this simulation. So look at the top. Why are we doing this simulation? We want to see the relationship between potential and kinetic energy. Okay. Then, once you say that, okay, we're trying to see this relationship between what did we change in the experiment? How does that affect the object? Okay, so you could say that as you increased this changed the kinetic energy. As you decreased this happened and potential energy changed. Okay, if we didn't apply friction, what were we able to observe? What law were we able to observe? And how were we able to see that? Okay, so you are going to write 4 to 5 sentences basically explaining what you did in the simulation. And you got to make sure you include potential energy, kinetic energy, mass, speed, and then the law of conservation of energy. So tie in those vocab words to what you did in the simulation, and you will be able to figure it out.